This podcast is sponsored by BPIExamPrep.com, the most affordable and effective way to make sure you ace any BPI certification exam. More at BPIExamPrep.com. Enjoy. Welcome to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford. Today we're talking about trends in high-performance building and retrofits with Joe Nagan, who is the owner at Home Building Technology Services in Kokona, Wisconsin. Joe, thank you for being on the show.
I'm glad to be here.
If you have not heard Joe's name, he is one of the most famous building science and implementation guys. So, Joe, how did you end up in this corner of Wisconsin, but still very famous at the same time?
Well, I personally lived here most of my life and then started getting interested in the building performance industry and worked my way up the ladder a little bit as I did my own private research and eventually started doing a little private consulting, and then our focus on energy program started in 1999, and it got me a larger audience. So I'm still tucked away, but I get out quite a bit.
Your private research involves walking down the street in your neighborhood and seeing some piece of equipment that's obviously malfunctioning, and you run over to it and start taking pictures. Do you do that all the time? Is that a habit for you?
Well, I have a golden rule. I never leave home without the camera. So if I'm in the van, I always have the camera ready to go on the passenger seat. And we do go around neighborhoods every once in a while just to take a look so we can get more ideas and more pictures and ways to identify and communicate with the people looking to improve their homes.
Mm-hmm. Awesome. Now, one of the most amazing things that you have done personal research on lately has to do with drying the foundation. Can you explain a little bit about what that is?
Sure. What happened, Corbett, was in our housing stock in Wisconsin, especially our newer homes, we have the building community doing some really good work in terms of air sealing. I mean, they really have these buildings dialed in. Hardly any active chimneys anymore with all the high-efficiency mechanical equipment, so there's not much natural air exchange for drying in the winter. Yet a lot of these homes are really well managed, even though they don't have large or big fancy mechanical ventilation systems. And it turned out that when we started to identify why this was happening in actually the opposite direction of what the average consumer would think, tighter buildings, less ventilation, that you'd have moisture problems, we recognized that a lot of these homes were being built under a holding company's name where they required an active radon system. And it took us a while to figure out the connection between drier buildings and a radon system, because we all recognized it's a subslab suction process that protects the building from upcoming radon. And but then after we got thinking about it, well, there's a lot of water vapor and a lot of liquid water in the foundation where the footings sit directly on wet soil when we build them, and the drain tile collect water, and even if there's not water filling the drain tile, there's still a half-inch, sometimes a couple inches of water laying in the drain tile, which means that the soil is actually going to be damp right next to the footing, and the footing sitting in that damp soil. So by capillary action, it wicks right up through the footing into the foundation wall poured directly on top. And even though some folks could say, well, why don't you just get the builders to do a capillary break? Well, we tried that, been there, done that. And you have to work with what the building community is willing to do. And we recognized that early on, and we don't fight them anymore, we work with them. So when we recognized that this water vapor was coming up and then evaporating in the first 2 feet roughly of the entire foundation 365 days of the year, we recognized that in addition to lifestyle moisture generation, a little bit of water vapor from showering and stuff, we recognized that there was a substantial load of water coming up from the ground in vapor form that we weren't accounting for. And with the radon systems in place, because they were running a reasonable large volume of air in a 24-hour period through the drain tile system and the gravel under a new home, providing that negative pressure under the slab to provide the protection on the radon side, all that air going through the drain tile and the gravel and out the exit pipe on the roof was taking everything else along with it, whatever was in the air. And it had this drying effect on the soil adjacent and underneath the drain tile. So when it dried that up, there was less water available to wick up by capillary and evaporate into the building. And that's where we first kind of figured out what was going on a little bit. And then we just happened to start talking to some of the homeowners in these homes and found out that the basements were really dry to the look. I mean, the concrete turns white. and that they even felt warmer, and it's quite often homeowners will actually tell you that the basements are warmer as a result of a radon system. And in some of the studying that the Energy Center did for us here a couple of years ago, they concluded as well that there is a small part of house air, a small portion of house air, that is being drawn under the slab around the perimeter of the basement slab, because it shrinkage crack around where the foundation slab butts up against the foundation wall. So it is taking a little bit of house air. We couldn't really quantify it exactly how much air. So if it's actually doing that, it's not only reducing the amount of water vapor coming up from the soil 365 days of the year, but it's actually then ventilating the building through exhaust only with no homeowner interaction whatsoever. And I thought, holy mackerel, now that's really good, because all our efforts to improve the mechanical ventilation equipment and its performance in the building is only valuable if the homeowner's willing to run it. And we found out from previous studies that homeowners don't want to run the ventilation equipment. So we thought, okay, if it's reducing the amount of liquid available to get in the building, we got less of a total load. And then we also have ventilation going on, so if it's exhaust, which it is, there's an equal amount, or roughly an equal amount of outside air coming in to replace that air, but it's usually coming in upstairs, and it drags some of the warmer air from upstairs down into the lower level in the basement, down around the perimeter, so it's warming everything on the way down. So we get warming, drying, less moisture load, and radon protection all in one shot. So our local radon specialist up in Neenah, Wisconsin, his company recognized that that was happening about the same time, because we were talking about this with him. And then it wasn't maybe a short period of time later, then they started marketing the system as an active dampness control system, ACD.
Wow.
Because most builders recognize that radon is important, but homeowners might not either find that they have a problem or think it's a problem, and then they won't allocate any money to do this. But when you start talking about moisture, both the builder and the homeowner gets interested, because they all know it's the trigger for other problems. And so it took off right away. I mean, they're doing this gangbusters up where we live. And the webinar we did last week, it had a ton of hits on it afterwards. So it turned out then that we were providing actual drying in the building at less cost than actually running dehumidification equipment, which was typically done, which couldn't provide any radon protection. So you wind up getting the moisture protection, and you can throw the radon protection in as a freebie, now provided that the system is done per the EPA's requirements for that installation, you know, the fan location and the whole thing. Because what happened is, when we first started letting people know that this was going on, builders were trying this because they knew that moisture was important to them, and they were going back on spec homes that they had sitting on the market, putting the system in, and calling back and saying, wow, dried that spec home right out. Basement dried right up, no greenish looking concrete, it's white, the whole shebang. And people are doing this in large numbers, and every time we talk about it. So anyway, we just had to make sure that people recognize that when you do that, if you're going to promote the benefit of radon, which it's doing whether you like it or not, that then the system really needs to be installed per the EPA's requirements, or even preferably by a radon specialist, so that the fan is in the proper location. Because what I'm seeing now is that so many builders are doing this for moisture, because it works, and it works every time. They're winding up putting an inline fan, but leaving it in the building, like going out the rim. That's not good, because you want the entire system always to be under a negative pressure, just like the slab. Because if you're sucking air with some soil gas in it, whatever that might be, and you draw it up out the ground, you know, up the pipe, up the basement wall, and then go out the rim with a box hill fan, but have that like inline fan in the basement, if the fan housing should crack, or the discharge piping coming out of the discharge side of that fan is not sealed, now you could actually be dragging soil gas from under the ground and then blowing it into the home. That's why we definitely don't advocate doing it that way. But it works spectacular on the moisture load, And we don't have any research to absolutely conclusively prove this, but we have been talking with the folks at the Energy Center. They're going to take another stab at it. But anecdotally, we got hundreds of stories of people calling us after doing this, and immediately within a couple of days seeing a major difference. Less runtime on dehumidifiers reported by homeowners. Substantial increase in basement comfort and temperature reported by just about every homeowner. We even had one homeowner where they built a new home, and I didn't know anything about it, but I got a call a couple months after they moved in. And the lady called me and said that they do the yoga mats on the basement concrete floor, and her daughter picked the mats up a couple days later and was soaking wet under the mat. And I'm thinking, well, it had to be water vapor coming up through the concrete slab, but that shouldn't happen if the poly is underneath there like our code requires. So anyway, I never even went to the home. I asked the lady, well, what are you going to do now? She said, well, the builder's coming back with the concrete guy. And I said, well, can you keep me posted? She said, yeah, I'll call you after they come back. So a couple days later, she called and said, yeah, they came over, Joe, and they drilled a hole through the basement floor. The builder wanted to see if there was plastic down there because there was obviously water vapor coming up and then getting trapped underneath that mat and then condensing. And that shouldn't be happening. So she called me back and she says, yeah, she said, they got a hole drilled in the concrete floor, and I still didn't go up there. And I said, well, can you look in that hole? And she said, yeah, I'm in the basement right now on my portable phone. And I asked her on the phone, I said, well, I don't know, can you reach down in there and do you see plastic down in there? She said, no, I don't see any plastic. I told her what I was looking for because the plastic is supposed to be right directly under the basement concrete floor. So I expected to see the ragged edge of that poly. And she says, well, no, I'm looking down there, I don't see that. I said, well, I don't know who you are, but are you willing to reach down in the hole and pull the gravel out? She said, well, yeah, I'll just dig down in there. So I'm still not up there. I'm just on my phone in the office. And she said, yeah, I'm pulling the stone out. And I said, okay, well, what do you get? Do you get to the bottom of the stone? She said, oh, yeah, I'm down on the bottom and it's just soaking wet. And I said, well, what are you looking at? I mean, are your fingers in the mud? She says, no, there's a sheet of plastic down there. Well, what happens is once in a while, the concrete guys, they know that if they put the poly up on top of the stone, the gravel base that's required here in Wisconsin, that now all the concrete moisture has to dry into the house and they got to wait longer before they can finish it. So once in a while, they'll slip the poly down before they put the gravel base. And then the concrete dries faster, but look what happens now. If you have the poly down there on the unexcavated soil with the drain tile laying also at that same level, now you're collecting water and putting it right on top of the plastic. Now all of that water has to dry into the house, and that was what was happening. So this is spectacular about what we're talking about here, is that the lady asked me what she thought she should do, or what I thought she should do, and I said, well, I'll tell you what, as long as you got that 4-inch hole in there, I'd be calling the local radon guy, having him come over and put a radon system in there, but do it for the moisture. Yeah. She called me back a week later, drier than a cob. She said that she can put her rubber yoga mat right back down on the concrete floor with absolutely no sweating, no coloring, no fading, no pattern of that mat whatsoever in less than a week. So it's incredible the amount of air that fan, those systems can move, and the amount of drying that it can do, even when there's liquid available. It's just the neatest thing I've seen in 25 years.
That's interesting. Is it important to plug the end of the PVC pipe that's going down under the slab into the drain tile, or can you just have it go into the gravel as you're describing?
In most cases, again, in my world, I deal mainly with new construction, so what we tend to do up here is actually put a T-fitting, a regular drain tile, the black drain tile, PVC fitting, made for that corrugated drain tile. So we snap that onto the end of a 3-inch PVC when we're roughing the system in. So that black fitting, the T is going right onto the white PVC 3-inch. And then when the guys come back to put the drain tile in, they just snap it in there like they're interrupting the drain tile. But you could, yes, just stick the end of that pipe right down in there.
Interesting.
But on new construction, since we have the ability to put that T fitting in there for $2, then we're telling them, okay, now you connect your end. You're just interrupting the drain tile, that one run, at that moment in time, connecting it. Now we know that we got a very good connection to the entire drain system, the bleeder tiles to connect to the outside, and to the sump crock. Real straightforward.
Awesome. You mentioned a few minutes ago what the building professionals will actually be willing to do. What do you see that does work really well, aside from your radon mitigation that has turned into a dampness control?
Well, that one is still one of the most innovative ideas with multiple benefits. The other part that I get involved in quite a bit, of course, is air sealing and mechanical ventilation. So we're seeing a lot more folks leaning towards exhaust-only ventilation, even in homes that are really, really well sealed. I mean, we have new homes up in the Appleton, Wisconsin area. It could be 3,500 square foot ranches with a full basement. They're getting them down at passive house tightness with hardly any spray foam whatsoever. But the folks are doing innovative detailing and they know where the holes are. So some of our framing crews are actually gluing the OSB sheeting on now to do the actual air sealing, putting their primary air barrier on the outside during the framing process, things of that nature. We got people doing low-cost attic air seal packages. Have you heard of that term before? I mean, attic air seal package?
No.
Well, what we found also, Corbett, is that we had a couple builders that were really into our Focus on Energy New Homes program that were really real good in support of the program and really way out there. But they kept after us. You know, how can we get the buildings tighter and tighter and tighter? And they were really beyond what we really would expect anyway at that point. But these were some guys that really wanted to know. So we started to do a little pressure diagnostics on the buildings to find out, okay, where could we even pick up any kind of pressure differential? And we found out we were still getting a little bit across the lid on the buildings. And when we started examining the framing process, we realized that all the interior walls are actually sticking into the attic, right? I mean, we butt typical polyethylene up to the double top plate of interior walls. And again, one of those ideas you asked me about that didn't work, you know, folks trying to put a piece of polyethylene, sandwich it between the double top plate to connect the continuity of the vapor retardant and all. We did that years ago. We don't do any of that hocus pocus. We couldn't get people to seal the drywall. They wouldn't do that like airtight drywall. We couldn't get them to seal the poly to the double top plate of a common interior wall. So recognizing that if you stood in the attic of a newly sheetrocked home, lit it up, and then walked around and looked at all the surface area of top plate that's sticking up, unsealed poly just butting up against that double top plate, and all of those interior walls are no different than a chimney chase. They're a chimney chase, but an attic wall, an actual interior wall with millions of feet of, well, not millions, but sometimes hundreds of interior outlets for home automation, pocket doors, all that stuff that no one would ever think about air sealing. But once that house air is in that interior wall and it gets past the drywall, past the unsealed edge of the top plate, it's into the attic. So what we had the foaming contractors do one time is just try one. We said, let's just go up there and weld that little gap adjacent to each top plate to connect that poly with spray foam from the top. So to get us a continuous air barrier without having to ask the framing crews to interrupt the framing and put a piece of poly, ask the drywall guys to do something we know they wouldn't do. We did that on 2 homes, and then using the Minneapolis leakage ratio on the Tektite software to account for the shell area, I mean, it was massive. I mean, those guys finally found what they were looking for, the last hole in that building that had any opportunity to show up on the blower door testing. And all of a sudden, that became what's known up there as the attic air seal package, and now everybody's doing that. So if we think about it, like you and I and the other folks are always talking about stack effect and where the pressures are the greatest, in our cold climate, I always tell folks, if you don't have much money or much interest in doing air sealing, do yourself a favor and do the lid first, because it's the place with the highest upward pressure all the time, with really the most holes, and we only got a one-sided surface to deal with. So unlike a wall where we have to have really 2 holes going through the building to have air flow, we only got one skin on the lid. And now everybody up there is doing the attic air seal package, and most of those same folks are doing the sub-slab mitigation on the ventilation system. So that went real well. That's a good one. Now, I just downloaded some pictures before where I went out and did some filming to show people how to do low buck attic air seal packages with RCD duct mastic. Works spectacular. So instead of spray foaming those top plates, just literally to weld that poly from one side of that top plate to the other. You don't need much of anything. We're just trying to fill that little gap. I'm going up there and showing them how to do that with duct mastic.
Wow.
And I work with a couple technical colleges where we work with students of all different ages and backgrounds. And we've been doing attic air seals on their homes now for 4 years, and they're getting them as tight and beyond some of our builder partners that have to pay for spray foam because they don't have the labor to go up in the attic. So there's a bunch of different ways you can do these things. And back to what you asked about, what the building community is willing to do. They're willing to do things if we can show them results that aren't, labor intensive and take them out of their normal pattern. So we're trying to work more with their trade contractors of their choice to make sure we identify what we're trying to accomplish on each building, looking at the options, and then asking them their personal comfort level. Well, what do you think about that? Would you be willing to do that? Well, I just really am not comfortable with it. Well, how about this option? And we just go around until we find an option that's comfortable with that particular trades contractor so that we get reasonable buy-in. And that's been working real well. The mechanical ventilation side, that's just all over the map. But we do find more and more and more builders, even with our ASHRAE 62.2 requirement for our focus program. It's not any part of our state code, doing exhaust only for this pure simplicity, dual function, spot and whole house at the same time. And that's working well because they're finally getting the ducting now to the point that the ducting is now allowing the fans to really haul the mail.
You are one of the most outspoken proponents of performance testing. One of your things that you're constantly shouting at your audiences in a very fun way is test, test, and then test. Are you finding that with all the training that's been going on around the country, that the contractors are actually testing their own work before they leave the site?
You mean the builder?
Yes. Oh. Whoever is doing whatever work in the house.
Oh, I see.
Do they actually verify that they did it right before they leave, or do they wait for somebody to find out that they didn't do it right?
I see. Well, I can tell you from the new construction side in Wisconsin, I don't know of one builder in the entire state that I know of that tests their own homes. And the only reasonable market that's being tested is usually through our program if it's new construction, but then it's only after the building is completely finished. I mean, we do site visits during construction to coordinate what the goals were during the process to identify the potential of getting where we need to be at the end. But I don't know of a contractor personally that has their own testing equipment, blower door. I know a few builders bought digital barometers for testing bath fans because they're definitely on board with the ventilation function.
Yeah.
But in terms of the air shell tightness, I don't know of anybody.
Interesting. Okay. Do you see that as a problem of going with kind of a rule of thumb of the attic air sealing package without actually testing it, or does it sound like it's working pretty well?
What happened on the attic air seal package is that because we worked with the insulators to tell them and show them what we wanted, they're not exclusive to us, right? So we were working with some builder partners in our program where we came up with that idea. Well, then they ran with it in their marketing department to tell every company and every customer that walked in their door, hey, we can insulate your building, we can do the normal code-required air sealing, but hey, the energy guys said that if we do this attic air seal package, it'll really haul the mail. So we see them doing that quite frequently because the builders understand what's happening, and when they tell them that we've kind of confirmed that it is working, they're selling that quite popular now.
Excellent. So are there any other tricks that you're using to help people sell this high performance, very practical applications that you're coming up with up here?
Well, that's still the part that everybody here at this conference struggles with. I mean, we all have the technical knowledge, if nothing else, to be able to communicate with each other to get what we need there. It's still the missing part of this. I mean, look at how many people we got here, 700 people. There's probably 2 homeowners here. Yeah. They're all out looking at pots and pans. So we're still trying to find what it is that tips them. But in our process, like in my private business and what I do with Focus on their new homes program, is to try and get our information in the building process early enough so that we can help the homeowner weigh choices that are available under their economic scrutiny and value system, so that at least they've had the option to look at what's available, weigh the economics, have us come in as a third party to say, yes, we know that that particular option works well. We could run the computer modeling to check optional energy cost savings, but it still is pretty difficult in terms of pushing it purely from the energy side, especially now where fuel costs are kind of going in the other direction. Mm-hmm. But we've made a pretty good inroad in terms of overall risk management for the building community. That one, we're still getting lots of traction, because even basic window condensation gets them in trouble. If they have window condensation, it's very likely that there may be a little bit of mildew or mold, which triggers the whole conversation about, well, what about the wall cavities and that? So we're getting some pretty good traction from builders that are willing to listen to the whole package, understand the risk management, and the fact that they may now be able to find some ways of doing things that are better than what they're doing, that help them a little bit with some market differentiation. But it's still a pretty good pitch.
Mm. Joe, thank you so much for being on the show.
Excellent. Let's do this again.
Joe Nagan is the owner at Home Building Technology Services in Kaukauna, Wisconsin. You've been listening to the Building Performance Podcast. I'm Corbett Lunsford. Tune in next time.